Good morning, guys. As a startup of physics, we are going to begin the first chapter of physics. The first chapter of physics it deals with the measurement and measuring instruments. In the introduction, they actually gave what is a measurement. Measurement is very basic and important thing for our daily life as well as the scientific studies. Now, what is a measurement? Measurement is just assigning the numerical value to an object or an event in order to compare that object or event with other object or event. To make it simple, we can define the measurement as just determining the size or magnitude of something. Following the introduction, we are having physical quantities and units. These physical quantities are classified into fundamental quantities and derived quantities. What is a fundamental quantity? Fundamental quantity means the quantities which cannot be expressed by other physical quantities, then it is called as a fundamental quantity. For an example, we are having length, mass, time, temperature. The quantities which can be expressed by other fundamental quantities and other quantities, then it is called as derived quantity. We are having examples like area, volume, and density. These physical quantities are having basically two characteristics. One is the numerical value and other is the unit. For an example, if suppose you are having 3 kg of an apple, that means here the number 3 is the numerical value and kg is the unit of that quantity. Now, what is a unit? Unit is the standard quantity of a quantity. Is that the specific magnitude of a physical quantity is called as the unit. These units are derived by law and convention. Earlier, we had different types of measuring systems like CGS system, centimeter gram second system, FPS system, foot pound second system, MKS system, meter kilogram second system. Like that, we had many different systems. But at the end of the Second World War, in the conference, the General Conference of Weights and Measures in 1960s, they actually derived a modernized and improved form of already existing system of measurements and units that is called as SI system. The abbreviation of SI system is International System of Units. These SI systems are basically they are having 7 fundamental units. If you take these 7 fundamental units, they are length. For length, they are having meter. For mass, they are having kilogram. For time, they are having seconds. For temperature, they are having Kelvin. For electric current, they are having ampere. For luminous intensity, they are having candela. For amount of substance, they are having moles. And the units which are used to measure the fundamental quantities, they are called as fundamental units, and the units which are used to measure the derived quantities, they are called as derived units. And now, from the do you know box, what is a fortnight? Fortnight is 14 days or 2 weeks of time. And next one, it is the moment. We usually tell people, wait for a moment, like that. Now, we are going to learn what is a moment. A moment is 1 by 40th of an hour. That is approximately 1.5 minutes of time is a moment. Next one, it is atomus. What is a atomus? The twinkling of an eye, eyelid shut time, it is called as atomus. The atomus time is 1 by 6.25 seconds. Is that 160 millisecond of time is an atomus. Next one, donkey's power. We usually heard about the horsepower. Now we are going to learn about a new term called donkey's power. What is a donkey's power is 1/3 of a horsepower. It is called as a donkey's power. It is measured as 250 watts. Next one, we are having fundamental units of SI system. In the fundamental units of SI system, first we begin with length. What is a length? Length is the distance between two known points, and the SI unit of length is a meter. If you take 1 meter, the value of 1 meter we can define as the distance covered by light in vacuum for 1 by 29 crores 97 lakhs 92,458 second of time. And when we are measuring this length, we have to measure larger distance as well as smaller distance. For larger distance, we are having measuring units like light year, astronomical units, parasec, and etc. So, what is a light year? If we take light year, the light travel for a year time in a vacuum, it is called as a light year. The value of light year is 9.46 into 10 to the power of 15 meters. And next one is astronomical unit. What is the astronomical unit? The distance between the center of the sun to the center of the earth, it is called as astronomical unit. So 1 AU, 1 astronomical unit, it is equal to 1.49 into 10 to the power of 11 meters. And next one, it is parasec. Parasec, it is a little bit bigger unit. This one is used to measure the astronomical bodies which are present outside the solar system. So 1 parasec, it is equal to 3.26 light year of distance. And next one, from the do you know box, we come to know that the closest star, it is called as the Alpha Centauri. It is about 1.34 parasec distance from the sun. And from the other do you know box, we are having another fact. Before going into that, we are going to see about the smaller distance. To measure the smaller distance, we are having some other units like angstrom, Fermi, nanometer, micrometer, and millimeter, centimeter, like that. We are having plenty of units to measure the smaller units, smaller distance. The smallest distance is the distance between the two atoms in a molecule. So this one is measured by angstrom. And from the do you know box, again we come to know a new fact that the distance of human blood vessel is 96,000 kilometer, and a camelin's tongue, it is twice as the length of the body of the camelin. And the newborn baby giraffe, it is 1.8 meter of height, that is almost 6 feet tall. And from the info bit, so apart from SI system, from the conventional time, we are using some other measurement systems like 1 feet it is equal to 30.4 centimeter, and 1 meter is equal to 3.2 feet, and 1 inch it is equal to 2.54 centimeter, and 1 meter is approximately 40 inches. And these kind of measurements we are using in carpentry works, plumbing works, and etc. And next topic, we are having mass. What is a mass? Mass is the quantity of matter contained in a body. The SI unit of mass is 1 kilogram. This 1 kilogram prototype model is kept in International Bureau of Weights and Measures at Sèvres, France. This prototype cylinder was made from platinum and iridium alloy. And now we will come back to the unit of this mass, that is kg. So in our smaller classes, we already studied about what is a gram, what is a milligram, what is a kilogram, what is a quintal, what is a metric ton, everything. I'll tell you one more time. So 1 by 1000th part of a kilogram is a gram. 1 by 1000th part of a gram is milligram. And 100 kg is called as a quintal, and 1000 kg is 1 metric ton. And next one, we are having atomic mass unit. This atomic mass unit is used to measure the mass of proton, neutron, and electron which is present inside a molecule. And 1 AMU, one atomic mass unit, its value is equal to 1 by 12th of a mass of a carbon 12 atom. And from the do you know box, again one more fact, it is 1 TMC. 1 TMC of a liquid, it is equal to 2.83 into 10 to the power of 10 liters. Otherwise, we can call it as approximately 3000 crores of liters. And next one, time. If we take time, we use time to measure an event, the duration of an event, or a time interval between events. So that is the purpose of time. The SI unit of time is second. So what is 1 second is? 1 second, otherwise we can tell as in 1 second of time what is the distance covered by light. That is called as 1 second. Is that, I'll make it clear that the distance traveled by light in vacuum at the range of 29 crores 97 lakhs 92,458 meters. This is called as 1 second. And it is also defined as 1 by 86th part or 400th part of a mean solar day. The largest unit of this measurement of time, we are having a day, week, month, year, and a millennium. 1 millennium, of course, 1 millennium, it is equal to 3.16 into 10 to the power of 9 seconds. And again from the do you know box, okay, we are having some facts about time. We used to have, our grandpas and our elders, they had this system. 1 hour, it is equal to 2.5 naligai, and 1 day it is equal to 60 naligai. That means they are having a day into one part and night into other part. They separates 12 hours, like that, a day as a 12 hour, from morning 6 a.m. to evening 6 p.m. is the daytime, and from evening 6 p.m. to morning 6 a.m. is the night time. Here each hour they said as 2.5 naligai. Then 12 into 2.5, it will give 30 naligai. Totally a day compiles 60 naligai of time. Next one, temperature. If you take temperature, we use temperature to measure the hotness or coldness of an object. SI unit of temperature is Kelvin. 1 Kelvin is 273.16. 1 by 273.16 is 1 Kelvin. The temperature at which the saturated water vapor, pure water, and melting ice are in equilibrium, it is called as 0 Kelvin, or otherwise it is called as absolute zero. The other units for measuring temperatures are Fahrenheit, Celsius, and here we are having some conversion table. From this table we can learn how to convert from Fahrenheit to Celsius, and Kelvin, from Celsius to Fahrenheit, Kelvin, from Kelvin to Fahrenheit, Celsius. I'll just explain, you try to understand. If you want to convert a value from Fahrenheit, temperature from Fahrenheit to Celsius, then you have to minus Fahrenheit value by 32 and you have to multiply it with 5 by 9. The value what you obtain is it will be in Celsius. And next, Kelvin. If you want to convert Fahrenheit to Kelvin, then Fahrenheit value minus 32 into 5 by 9 plus 273. It will give you the value in Kelvin. Next one, conversion of Celsius value to Fahrenheit and Kelvin. First we will do it with Fahrenheit. If you are going to convert a Celsius value to Fahrenheit, then you have to multiply the Celsius value with 9 by 5 and then you have to add it with 32. It will give you the Fahrenheit value. If you want to convert the Celsius into Kelvin, then directly add the Celsius value with 273, it will give you the Kelvin value. Now conversion of Kelvin to Fahrenheit and Celsius. First we will do with Fahrenheit. If you want to convert the Kelvin to Fahrenheit, then Kelvin value you have to minus the Kelvin value with 273 and then you have to multiply it with 9 by 5, then add it with 32, it will give you the Fahrenheit value. And if you want to convert the Kelvin into Celsius, directly you can minus the Kelvin value by 273, you will get the Celsius value. Next one, unit prefix. What is unit prefixes? This unit prefix is just the order of the magnitude of the quantities. It is very well explained in the bottom table. Like the peta is 10 to the power of 15, tera is 10 to the power of 12, giga is 10 to the power of 9, mega is 10 to the power of 4, kilo is 10 to the power of 3, hecto is 10 to the power of 2, deca is 10 to the power of 1, deci is 10 to the power of minus 1, centi is 10 to the power of minus 2, milli is 10 to the power of minus 3, and micro 10 to the power of minus 6, nano 10 to the power of minus 9, pico 10 to the power of minus 12, and femto 10 to the power of minus 15. And the next topic is rules and conversion for writing SI unit and their symbols. Here we are having 10 points. The first point is defining that the unit which is named after the scientist. Okay. Here we should not write the initial letter in a capital letter. Say for example, if we are going to write Newton, we have to write the first letter in capital. That is, N will be in capital. Usually we used to write like that. But when you are writing the unit which was found by a scientist, derived by a scientist, and we are giving the name after the scientist name, when you are writing that unit, you should not write the first letter in capital. And second point, if you are going to write symbols for the unit which is named after the scientist, now these symbols are written in capital. The first letter alone written in capital. For example, Newton, we will write the symbol as N, capital N. The third point. In the third point, they are explaining. Now, we are having some small letter symbols also. These small letter symbols are not derived by a proper, now not found by a proper scientist. Okay. So, these things are in smaller letters. And fourth point, no full stops or punctuation should be added at the end of the symbol. And fifth point, the symbols and units should not be expressed in plural form. And the next sixth point, it is talking about the temperature. The temperature will be expressed in Kelvin. When you are expressing the temperature in Kelvin, you should not use the degree sign. But of course, if you are going to mention it in Celsius or Fahrenheit, you can use the degree sign. The seventh point, it is talking about solidus. Solidus is the slash symbol, division symbol. You cannot use more than once the solidus in a unit. And next, eighth point, we have to write the symbols and units, numbers and units with proper spacing. And ninth point, only accepted symbols we have to write. Like for an example, when we are writing about, when we are talking about seconds, we usually write as SEC as second. This is wrong. Of course, we have to write in a full form, second, fully. And the last point, when we are talking about a physical quantity, numerical value of a physical quantity, we have to express that in full scientific form. Like when you are, for an example, when you are going to explain the density of a mercury, you should write it as 1.39 into 10 to the power of 4 kilograms per meter cube. Not like 13,600 kilogram per meter cube. That's it. So second session I'll send you Afterwards, the first session of class is over. Thank you guys.